Hello everyone, today we will take a look into the first part of software architecture, and we will take a look what it is software architecture, what is the definition of software architecture, what influence to software architecture and stakeholders. Let's start. So first, what it is. Let's start from the definition. Software architecture of a system is a set of structures needed to reason about the system, which comprise software elements, relations among them, and properties of both. It means software elements and relations, properties for both of them. There are a lot of definitions what it is. This is most of the common definition that allow us to understand the basic idea that we are going to work with structures which consist of elements and relations among them. What it is and what it is not. So architecture is a set of software structures. It's not just only one diagram, it's not only one structure that can represent the idea of all system. In case if, for example, I will show you one of the structures, one of the image, then in most cases, it would not be, we are not able to call it as an architecture. The one structure, the one set of view will not present the full system. You will not be able to understand the full picture just using the one structure. So it always the set of views. It's also quite important to, and we will take a look at later, what kind of set it can be and what kind of views it should be. It also doesn't mean that any presentation, any view can be used. It's not. What else? So architecture is an abstraction. Because the architecture consists of structures and structures consist of elements and relationships, it follows that an architecture comprises software elements and how the elements relate to each other. In most of the cases, it is an abstraction of system that selects certain details and suppress others. So it doesn't mean that you have to present or concentrate in all of the details. You have to choose the most important one, and in quite level of abstraction, represent your view, your ideas. What else? Every software system has a software architecture. Even the simplest code contains architecture, it's software architecture. So even the most trivial case, the system is itself in, even if there is just only Hello World application, it still have architecture nevertheless. But it doesn't mean that it will be known to anyone. Even if you will imagine that each person will design the system, each time it will be quite simple. Each time it can be different, and if it is not documented, if there is no documentation, then it will not fulfill for understanding for others. Architecture includes behavior. What does it mean? The behavior of each element is part of the architecture insofar as that behavior can be used to reason about the system. It explains us how the elements interact with each other. And also it tells us how these box and lines passed of the architecture by itself. Not all architectures are good architectures. There is no strict rule what is good and what is bad. We have to think from the perspective that how our solution will be relevant, will correspond to particular requirements that is expected from the design. Let's move to the next slide. So, architectural structures and views. As we mentioned before, we are not, and we should not, take a look into the system just from one perspective, from one point of view. Here, as an example, you can see, for example, different structures of the car. And it depends from what kind of specialist will work with it. If we are talking there, for example, general, the engineer, he will take a look from one perspective. If we'll considering the perspective from specialist in electronic systems or electrics, then he will be interesting in other things. If the specialist from suspension, for example, for the car, he will take a look for another perspective. So it's like X-ray for which will able to present us different kind of views, depends what is interesting for us. So what is the view? The view is a representation of a coherent set of architectural elements as written by and read by system stakeholders. So it depends what is interesting for system stakeholder of our software system. It consists of representation of a set of elements and the relation among them. So it's quite important that you have, first of all, identify your stakeholders and to whom you are working with inside the project, and what will be interesting for them from their perspective of view. If you will create the maybe brilliant solution, brilliant design of the system, but from the perspective that is not interesting for them, they are not specialists in this area. They're interested in completely different things. So your result will not have any value. The structure. The structure is a set of elements itself, as they exist in software or hardware. So structure is a set of elements itself. We can say, in other words, that a view is a representation of the structure. So architects design the structures and they document views of the structures. This is the main definitions of what it is structures, what it is view. There are three kinds of structures. It is model structures, component and connector structures, and allocation structures. Each of these structures will answer for different questions. For example, the model structures. We can ask the next questions. What is the primary functional responsibility assigned to each model? What other software elements is a model allowed to use? What other software does it actually use and depends on? For the component and connector structures, we can raise next questions. What are the major shared data source? Which parts of the system are replicated? How does data progress through the system? So I suppose that based on these questions, you can guess what is the nature of each of these structures. For the allocation, for example, what processor does each software elements execute on? Is what directories or files is each element stored during the element development, and so forth. Let's try to conclude what we are talking about. So the model structures show how a system is to be structured as a set of code or data units that have to be constructed or procedured. Component and connector structures show how the system is to be structured as a set of elements that have runtime behavior, component and interactions, its connectors. So when we are talking about component connector structures, we are talking about runtime perspective of view. Allocation structures show how the system will relate to non-software structures in its environment. So we are talking about CPUs, file system networks, and so on. Here you can see the next step is related structures to each other. So and some useful model structures, some useful component connector structures, and also allocation structures, as an example. So as you can see, for example, we can have such model structures as decomposition, as users, layers, class, data model. Each of the structure can have different kind of element types. It can be model, it can be layer. When we are talking about the class, it is class or object. When we're talking about the data model, it's data entity. So I suppose it's became a little bit more clear that first, we have different, to describe something, we have to have different kind of perspective, different kind of point of views. It's not possible to present the system just from one point of view. We have to take a look from different point of views. These different point of views we can divide for different structures. It's model view structures, component connector, and location. For the model structures, for example, there are several examples. It's the composition, users, layers. Previously, we already take a look for the layers. And we start working with, for example, with the layers. Also, we touch, for example, classes, and use class and object as element types. The relations, yeah, but we still didn't look for data model previously. The relation for each one is different. So for the layers, for example, it requires the correct presence of users, of services, of provides abstraction to. When we're talking about the classes, we're talking about instances, shared access methods, and so on. We have to understand for which one they are useful. And also we have to put attention for quality attributes, which will be affected. The quality attributes play the key role in our decision when we're trying to design something. So it means that depends on quality role, you can make a decision what kind of software structures is better to represent your perspective, your point of view, your decision. For example, if we're talking about modifiability, decomposition, because what? Because system will be modified quite rarely, or not rarely, sorry, frequently. So that's why, and by the way, in the modern life in nowadays, the time shows that this is one of the key point quality attribute, modifiability. Previously, when the system was designed, the process of development was a little bit different. We'll take a look at later. In most cases, the waterfall approach was used. So it means that the system was designed, it was implemented, tested, and delivered, and that's all. Nowadays, this development action is repeatable. It's kind of iterations. It never stops. The software always updates. New features are added, so it always modified. That's why this is one of the key quality attributes right now. And when we design the system, we have to keep in mind it, and in most cases, we have to use such structures as decomposition and work with models. Portability, for example, if we're talking with portability, then we have to pay our attention to the layers. Maybe we can represent our ideas by the layers of the structures. Extensibility, performance, for the performance data model can be used. For the connector structures, service, and concurrency. So this is how our model how our elements will communicate with each other. So for the services, in most of the cases, we have to work with services, with registry, ESB, how they will run concurrently with schedule analysis, performance analysis. In most cases, it is relevant to the interoperability and modifiability, concurrency nowadays. So performance for sure. So if the performance of the system is the key argument, is the key point, then maybe we need to use structure that will concentrate on how we will resolve these issues, because they are the most important. They will play the key role of success of our project. For example, it means that, let's say that the system will not be successful if it will work slowly. And for example, you will concentrate on, let's say, layers presentation. Does it make sense? No, it doesn't. So because the layers shows you that how you will resolve the issues with performance. The issue with performance will be resolved in most cases by concurrency. So this kind of structures should be used, and you have to present how you will resolve these issues in particular cases. What else? Yeah, let's move forward. Maybe we'll come back for some of the structures later on. So common module, yeah. Just one word that I want to say, that you have to keep in mind that different view, they can be let me just quickly come back. I have to tell you one thing, that sometimes it's not enough to have just only one representation of structure. Sometimes you have to combine both of them to take a look from different perspectives. They will show you completely different things. So just keep in mind that combination of these structures regularly requires. Architectural patterns. So sometimes architectural elements are composed in ways that solve particular problems. These compositions have been found useful over time and over many different domains, so they have been documented and disseminated. So they are called architectural patterns. These approaches that was used previously, and they were used successfully. Here is the common module type patterns. For example, it is layer pattern. It's not just only the single one, but it's the common one. So when the user's relation among software elements is strictly unidirectional, a system of layers emerges. Common component and connector type patterns are shared data patterns and client-server patterns. Shared data patterns comprise components and connectors that create, store, and access persistence data. So in most cases, we are talking about SQL. Client-server patterns, the components are the clients and the servers. And the connector are protocols and messages they share among each other. This part is interesting for us. Allocation patterns. Common examples is multi-tier pattern and components center and platform. For example, in component center, work is allocated to sites depending on the technical or domain expertise. Let's move forward. The big topic, quite a big topic. Why? Why is the software architecture important? As you can see, there are quite big list of points that the reasons why it is. Let's try to move one by one to answer. So the architecture inhibiting or enabling the system quality attributes. What we are talking about here? We are talking about quality attributes. So it means if your system requires, for example, your system must be high secure, then you need to concentrate on protecting communication and control which elements are allowed to access to one other. If, for example, your project need to have ability to deliver incremental, so you have to concentrate on intercomponent usages and so forth. So that's why it is important. Because if you will design a complete system which is not fit expectations, no one will use it. Reason about the managing change. Actually, we're talking about it previously. It is about modifiability. Nowadays, all changes are incremental, and most of the project they continue changing. But the question is, what kind of changing? What kind of modifiability? If we are talking about the local changes, which will be, for example, you have to change some comment or change the field name, it will not cost you too much. But if you make a mistake or you want to have significant architectural change affect the fundamental ways in which the elements interact with each other, and it will probably require changes all of the system. So the cost of such changes will be significant. So that's why we have to work with design before we start of the system. It will give us the answer how to prevent such situations in future when we will see the full image, what we are going to design, what will be, how should we resolve issues with modifiability, what if it will be requires to change one part or another one part, how we will deal with this, to be ready for this, to design system in mind of this, that to decrease the cost of these changes, to be even to be able to do this. Next is predicting system qualities. Predicting system qualities, it means that if you will have the design, if you will have the software architecture, before you will start the development, you can even predict the behavior in most of their cases from your expectation. Yes, it is based on your experience, on previous experience, but without it, the chances that you will face with errors, with not errors, with mistakes in your design, and you will build a system which is not expected by owners or customers who order the system, will be quite significant. So that's why it's, but in vice versa, if you will have the design, then you can predict some characteristics. The performance will be quite good? What about availability? Will it work or not? And so forth. Communication among stakeholders. Yes, this is another point why it is quite important. Because if you want to explain something or you want to communicate with key stakeholders on your project without knowing it, without this representation, your explanation can be incorrect, or they can be you can skip some details, or another persons with which you will communicate will understand you in a different way, which is not expected, or so it possibly can lead to mistakes on the future of the project. Carrying early design decisions. It's always about the decisions. And if you will prepare the architecture, then it means you can figure out this in early stages. So the process of development, it's always the decisions. In each step, you will design how you should implement it. But if you will see the full picture and you will see the influence between your decisions, what will be the result of your decision in the future, and you will be able to change it before you start the development process. Defining constraints on implementation. It's also quite important, because by defining the constraints, you can limit the opportunity, not the opportunity, but you can limit the possible wrong ways for the development team. With the constraints, the way, the path for the development team will be more strict and more clear for them. Influencing the organizational structure. Yes, it also can influence the organizational structure when you will understand how many efforts you need, how many developers, QA engineers, DevOps are required. So it has the influence of the organizational structure. Enabling evolutionary prototyping. One of the key point is the benefit that you can prototype quickly your solution, to put the main ideas here and see how it will looks like, just with quite less functionality, and later on you will just increase this functionality. Improving the cost and schedule estimates. It's quite important for the management, for the customers to know how much it will cost and what time it will take to implement. Without seeing the picture of your goal, how you will answer for these questions? It will be just guessing. But if you will speak with all your stakeholders and show them your vision, your structures from different point of view, you can make estimates from your side. Management can make estimates from their side. Development team also can be involved into this process, and they can provide estimates also. By the way, I don't see the timer, and I don't know when the Zoom will drop us. So we'll continue after that. Be ready. Let's continue. So what else? Supplying transferable reusable model. The quickly answer for this is that once you apply your solution, you can transfer your solution to another cases. So development in the future will be faster, and it will be more clear for you how to how to prevent some mistakes in future. Allowing incorporation and independent developed components. Yes, it's also about it, that you can use your components, and the components will allow you to get the results faster than previously. You can reuse all the existing components, and moreover, all modern technologies, they move on the way that the components used as much as possible. To do why they do this? To make it simpler. No need to have specific knowledge in specific area. You can use already implemented functions wrapped by component to achieve one of the results. Restricting vocabulary of design alternatives and providing basic for training. Let me quickly say that, for example, even the new members of the team will involve to your project, then it will be much more easily for them to explain what you are working with, how the project looks like. Let's move to the next slide. So the next point is the many contexts of software architecture. We can divide these contexts for the next one. It is technical, project lifecycle, business, and professional. Each of them relates to next question. For the technical, for example, what technical role does the software architecture play in the system or system of which it's part? For the project lifecycle, how does the software architecture relate to the other phases of software development lifecycle? How it is related? From the business perspective, how does the presence of a software architecture affect the organizations of business environment? From the professional, what is the role of software architect in an organization or development project? Also, let's take a look for this key context from next perspective. The technical context, it inhibit or enable the achievement of quality attributes. We already talked about it. So, for example, if you are care about system availability, you have to be concerned with how components take over for each other in the event of failure, or how the system responds to the fault. If you are care about usability, then your concerns will be different, and so on. This is about the technical. Architectures and technical environment. This is quite interesting point, what it is about. The idea is sometimes it happens that you can combine things that looks like is not can be merged all together. For example, so this is always about